Assalamualaikum warahmatullahi wabarakatuh. Good evening. My name is Faisal with the ID 4212301084 from the class Mechatronics C morning semester 5. And today I would like to explain to you guys the implementations of uh, MNIST dataset classification using HOG and SVM features, and as well as the evaluation of the dataset using live one out cross or LOOCV. Now, in this video, we will include the data processing, the parameter that we use in HOG and SVM, the evaluator, which is live one out cross validation, and the results, the metric and such. So here, as you can see, this is the main program, main code, and here we have the initializations with the configurations. That is the scikit learn. We are using, of course, live one out cross validation, and here we are using progress bar, and we are going to ignore all the computational process warnings. So basically, it's going to ignore every warnings about the process. Here are the global variables. This is the samples per class. This is the how many samples we will take per class, and this the total samples is the how many class there is. We are going to use 26 times samples per class, which is the total samples. And this is the file path here. This is the directory of the CSV file. So we are going to use this datasets MNIST_strain.csv to do our sampling and evaluating. So the output path, this is basically just the for the evaluation logging and the metrics, the results. These are the HOG and SVM parameters. The rotation is 9. The kernel mode that we use will be linear, and it's not just linear. They're like K-fold, RBF, and I use linear because it's the most optimal. It's the most learning friendly, and it's not as slow as RBF because RBF is very accurate in terms of doing the sampling. I've tried RBF and it's taking too much time to do the overall process. This is the C parameters, the PPC, pixel per cells per block. Now you can actually tune this to variables. Here I'm using 8 and 2. You can actually make it more accurate by reducing the value of each one of these variables. And this is the mode of the evaluator, which we are going to use. That is the LOOCV or uh, leave one out cross validation final true. This is the mode. This is just the logging and visualizations. Basically, this is what after the process has finished, we're going to get a logging message and also the visualizations of the metrics, the results of how accurate our process is, our sampling process, our evaluating process. This is the loading data and sampling data, which is, as the name suggests, it's basically we'll take the data from the dataset, that is the CSV format, and we're going to sample that using the HOG and SVM features here. This is of course the progress bar features for the HOG. Now many will say that progress bar is not uh, essential in this program. But let me tell you something that I've actually experienced. If you are running a program or code that is taking too much time and you need to really keep a track on it, you really need a progress bar to know how far the program has succeeded. So this is actually very crucial right here. And the parameter tuning, here is the parameter tuning. This is the evaluation, the final evaluation. So after the sampling is done, which is the HOG and SVM, it will go to the next phase, which is the evaluation. Basically, it's like checking how effective it is, how optimized it is, using LOOCV or leave one out cross validation. Small SVM kernel, how much iteration, max iteration, the accuracy score, the time. Of course, we need to keep track of the time. The write log, basically telling us what the state of the processing is currently in here. So this is the main function. Of course, we need a main function to process, to basically just function to make the program functions. Here, the MNIST classifications. MNIST is the dataset. We need to classify every data there is to basically in 500 samples per class, which is 26 class, which is about 13,000 sample. This is what happens if the file is not found. Parameter tuning, the final log the evaluations. Okay, now I'm going to explain to you guys about the table, the results. I forgot to mention that we are using histogram, basically HOG or histogram oriented gradient is a type of features that can basically recognize an object or maybe letters or numbers, as well as SVM is basically some type of classifier, making class and differentiating it with other other samples, and we are using linear. And then LOOCV is basically, it's going to first test one samples, for example one samples, and then it's going to train it. So basically it's per sample, test first and then train. Okay, here we have the table. Here's the true label, the predicted label. The true label is the actual label, actual reading, and then the predicted label is the horizontal one, which is basically predicts the outcome. So here, for example, for A, we got basically 390 successful classifications, and this diagonal is basically the successful classifications, and the other one is misclassifications. For example, here 390. For the L, there's a lot of misclassifications, as well as I, G, Q. Okay, so here we can see the output log. Basically, we have 81.08% accuracy, the accuracy that is of the LOOCV. Now I can actually cramp up the accuracy, maybe using a better kernel or reducing the PPC and CVP values like I mentioned earlier. That's all for me. Thank you.